all my viewers and students, Assalamu alaikum. Previously we start our chapter force and motion. In that class we have discussed about the force, unit of force, inertia, law of inertia, and Newton's first law of motion. Today we will start the next topic, Newton's second law of motion. As we know that if we applied a force on a body, the body come into the motion state and start to move from one place to another. That means acceleration produced in the body, because it is initially at rest, but after the application of the force it start to move. So that means change in velocity per unit time produce acceleration in the body. According to Newton's second law of motion, or statement of the Newton's second law of motion is, when we applied a force on an object, it produces acceleration in the direction of the force, which is directly proportional to one another. That means acceleration produced in a body is directly proportional to the force applied on it, and acceleration is always produced in the direction of force. As well as the body has some mass, this acceleration is inversely proportional to the mass of the body. So when we start the Newton's second law of motion, first we write the statement of the Newton's second law of motion. Then we prove F equals to ma. That means force is always equals to mass of the body multiplied by acceleration produced in it. Statement: consider two bodies having the different masses, applied same force. That means if we apply the same force on the body which has very large mass, produces less acceleration as compared to same force applied on an object having the light mass. If the two bodies having the same mass, we apply the different forces. We applied the two different forces. One is large and other will be small. Having applied on the same mass of the body A and B. So the large force applied on the body B, therefore the body B produces more acceleration as compared to the body A, because the small force applied on body A. According to Newton's second law of motion, acceleration produced in an object is always directly proportional to the force applied on it, as well as In other words, when we applied a force on an object, the acceleration produced in the direction of the force applied on it is directly proportional always, and acceleration produced in the body is inversely proportional to the mass of the object. Mathematically, we write as acceleration directly proportional to force applied on it when constant mass. Similarly, this acceleration produced in the object is inversely proportional to the mass of the object for constant force. Combining both of these relations, we obtained A proportional to F multiplied by 1 upon M. That means A equals to K F upon M, where K is called constant of proportionality. If we applied unit force on the body of the mass 1 kilogram or unit kilogram, that means if K is equals to 1, then A equals to F upon M. And this relation is changed because M in the denominator come into the multiplication form. On the other hand, the relation we obtain F is equals to MA. This is the final equation of the Newton's second law of motion, in which force is equals to product of mass and acceleration. This force is is a vector quantity, and acceleration produced in the body is also a vector quantity. But in SI system of measurements, the unit of force come as, according to the Newton's second law, force is equals to mass multiplied by acceleration. The unit of mass in SI system is kilogram, and acceleration has the unit meter per second square. Therefore, it comes as kilogram into meter upon second square, and this term kilogram into meter per second square is named as Newton. And this is abbreviated by capital N, and this is the unit of force in SI system. Okay, now definition of 1 Newton. How we explain 1 Newton? That means when we applied a force of 1 Newton on a body having the mass 1 kilogram and produces 1 meter per second square acceleration. 1 Newton means when we applied a force on an object having the mass 1 kilogram, produces acceleration in the direction of the force 1 meter per second square, it comes as Newton or 1 Newton. So I hope all of you understand the Newton's second law of motion, by which we derive the unit of force or a equation for the force F is equals to ma. Again I repeat it, when we applied a force on an object, it produces acceleration in the objects in the direction of the force applied on it is directly proportional to each other, and this acceleration produced is inversely proportional to the mass of the body, which I solve or mathematically on the board which you look at and watch in the video. Students, now we come to the Newton's third law of motion. This is a very simple law. To every action has an equal and opposite reaction. That means if we throw a ball on the wall, when it strikes with the wall and it come back in the backward direction. When we throw the ball, this is the action. When the ball comes after the collision, it rebounds or it come back is the reaction. To every action has an equal and opposite reaction. That means when we walk on the ground, we push the ground in backward direction. But another example, after the ball example, walking on the ground is the best example. Swimming in the water is another example of the third law of motions. And an object placed on the surface of a table, that means the weight of the object acts downward, but another force applied on the object in the upward direction, which is always equals to the weight of the body, and this is known as the reaction force. That means weight of the body W is equals to R, the reaction force. That means the box or any object lies on the table until we applied a force on it. So these are the example of the Newton's third law of motion. Similarly, the movement of a rocket when it moves from earth to upward direction. This is another example. Walking on the ground, swimming in the water. Similarly, when a paratrooper jumps in the sky is also known as the third law of motion.